Hello everybody, how are you doing? Today we continue our work on linear algebra and we'll today take apart one new topic, and it is about equations of the line. You have to read your reading part of your work because I gave you a very good observation of this topic, but I give here some basic concept to make your reading and you working on your individual work easy, to facilitate your work here or your educational way. So equation of the line. At school I know that you were used to some linear function at xy coordinate system. So y equals something like b plus kx. Here b and k, they are numbers. So k here the factor or the slope of this straight line, and b like an interception, x interception of the y. Remember we say it. So this is the equation of the straight line. In 3D space, we have a little bit another situation. For example, and we deal with ND space. I have an arbitrary line here, and for example I have a point P0. I know this point P0, R0. It is a radius vector of the point P0. I remind you that the radius vector connects the 0, 0 point of the very beginning of this system of coordinates and point, and the given point. For example, for P0, R0 is a radius vector. And if I have any arbitrary point here P, the vector which connects, I'm failure at connection here, R1 as a radius vector, or just R. I don't need this one. Index here is a radius vector of the P. And for example, I have a Q vector which lies at the straight line Q. Q vector, I can denote vector P0P like some number t times Q. So you remember this product by a scalar of the vector. T is a number, and this t times q equal at the same time like r minus r0. So this way to define the straight line which go through the point P0 and have directed vector q is known like a vector equation, a vector equation of the line. At the same time, we can convert this vector equation into the components way to write down. So what does it mean? It means that x, for example, minus x0 equal t times x, component of the vector q. The same thing about y, minus y0 to t times qy. So it is for 3D space, for example, space. And z minus z0 equal t times qz. This view this is the same line, but we change a little bit the way how to define the components of this vector r through not through the vectors but through the components of the vectors. This way to write down the equation of the line is known as a parametric equation of the line. But you can notice that all of these three components, they have the same number t, and t equal y minus x0 over qx. Simultaneously it is equal y minus y0, z minus z0, and it's equal simultaneously it is y minus y0 over qy and z minus z0 over qz. This way all the equation of the straight line is known like a canonical equation of the line. So there are three ways here. A vector, which is the t times q vector equal radius vector of the arbitrary point minus r0. We have the second one way to write down the parametric equation of the line, and the third one way a canonical equation of the line. Some practice. And the very first job here, we have to define, for example, we have 2 points, example 1. We have 2 points, A, for example, equal 1, 2, 3, 1, 3, 4, for example, has components. B has components, I don't know, minus 2, 0, 5, and I want to define equation of the line. I put here EL to reduce our work is unknown. So let's define the equation of the line. So we have 2 points, A point here and B here. Reduce vector, RA, RB here. And I want to write down the equation of the line. So I can use the canonical U. So I have here x minus x0 over qx, z minus y minus y0 over qy, and that is equal z minus z0 over qz. Here. So x here, they are variables, exactly like in our equation y equal kx plus b here. Okay. So to define the equation of the line, of the line, I have to define, we have to calculate, we have to know x0, y0, z0 and qx, qy and qz. x0, y0, z0, it is very easy to define. You can use coordinates of the a or of the b, it's your choice. So x0, y0, we can take 1, 3 and 4. So on the other words, they are coordinates of either a or b. It's your choice. I like a, so I took the coordinates of the a. What about q? Q vector I can take as a vector ab, and you can take away from the, if you remember, head minus tail. So I can take the coordinates of the head b and take away from the b a coordinates. So I have minus 2 minus 1, 0 minus 3 and 5 minus 4. Since that I have minus 3, 1. So this vector q gives me numbers for qx, qy and qz. Since that, the answer is the following one expression: x minus 60, 1 over minus 3 equal y minus 3 over minus 3, and the last one z minus 4 over qz is 1. So all points with components x, y, z which satisfy these three equations, x minus 1 over minus 3 equal y minus 3 over minus 3 equals z minus 4 over 1, all of them lie at the given line. So we have here the answer. The answer.